Hello everyone, in today's video, we are gonna discuss about how to tell whether some known vectors are linearly independent or not. We begin the class with the coefficient vectors in the linear system. Here is an example. In this example, a1, a2, and a3 are the coefficient vectors, which can be also called the column vectors. The linear system can be written in the form of a vector equation. The 0 on the right-hand side is actually a zero vector. When it's zero vector on the right-hand side of the vector equation, we know the linear system is homogeneous, and it has a trivial solution with all unknowns to be zero. Let's go back to find its general solution. We are familiar with the process already. Just simply apply Gauss-Jordan elimination to the augmented matrix of the linear system. We can get the reduced row echelon form, then the solution set. In this example, the general solution is exactly the trivial solution, which is the unique solution of the linear system. In this scenario, we call the coefficient vectors are linearly independent. How would this happen? Let's have a little bit more observation. It's not difficult to find in this example there is no free variable in its reduced row echelon form. In other words, the reduced row echelon form has a pivot in each column. This example is a homogeneous linear system with only one solution, which is the trivial solution. What if it's an inhomogeneous linear system? Recall what we have learned in the last video. The general solution of an inhomogeneous linear system can be obtained by adding its homogeneous system's general solution to a particular solution of the inhomogeneous system itself. Therefore, it can be easily concluded that if the coefficient vectors in an inhomogeneous linear system are linearly independent, the inhomogeneous linear system has at most one solution, because there might not be a particular solution for the inhomogeneous linear system. In general, the three statements in the green boxes are equivalent. When you observe one of them is true, you can conclude that the coefficient vectors are linearly independent. Let's have some practice with another example. Try to find out whether the three vectors are linearly independent. If we treat the three vectors as the coefficient vectors in a linear system, we can put each vector as one column of the coefficient matrix, after which we apply Gauss-Jordan elimination to get the reduced row echelon form. Then we can form up a homogeneous vector equation that has a non-trivial solution holding the equation. Let's look back at the reduced row echelon form. We found there is no pivot in the third column. So far, we have found two evidences that are against the three statements supporting the vectors are independent. So we can conclude that the three vectors are not linearly independent. In other words, they are linearly dependent. Actually, one evidence would be enough to get this conclusion. That's all for today's video. Hope it can help you understand how to determine whether given vectors are linearly independent or not. If the content helped you, please thumbs up and subscribe to my YouTube channel. Your support will drive me making more great videos. Thank you.